Our speaker, Dr. Ashwin Kothari. We have with us today our speaker, Dr. Ashwin Kothari, who received his BE and MTech degrees in Electronics Engineering and PhD from Vishwesvaraya National Institute of Technology, Nagpur, where he is currently working as an associate professor. He is the coordinator for Center of Excellence of Embedded Systems, Hybridization of Communication and Embedded Systems under World Bank Assisted Project of TechCube 1.2.1. He has authored numerous publications in SCI journals and has contributed book chapters for reputed publications. He has more than 20 years of teaching experience. His research areas include variety of areas including antennas, wave propagation, communication, image processing, electromagnetics, and rough sets. I welcome you, sir, for this session. I request you to please take over the session. Thank you.
Thank you, Dr. Vipin, for your generous introduction. A very good morning to all. Hope I am audible.
Yes, sir, you are audible.
Yeah. So, is my screen visible?
Yes, sir, it is visible.
So, are the slides changing at your end?
Yes, sir, they are changing.
Okay. Thank you. So, during my introduction, as it has been already told to you people that RoughSet is one of the areas in which I work or usually of interest and all. And as the thematic area of this particular MDP is artificial intelligence in image processing. Now, when we talk about AI and its complementary term of soft computing, we find that it basically has unification or amalgamation of many tools or technologies together to yield basically a very good knowledge data discovery out of the available humongous data with us. So the data here, especially which we are discussing, is image, and therefore how the hybridization with different approaches for this technique can help you is the main focus of my discussion basically. So you will find that before I start with my forward talk, I would just take 5 minutes of yours. In VNIT, we are hosting a Center of Excellence of Embedded System, that is hybridization of communication and embedded system, which is set up with the World Bank assistance under program of TechWhip, and it is called as Center of Excellence of Embedded System. And so far till date, whatever grant it has received is to the tune of 90 million US dollar, or in Indian rupees 9 crores of rupees. So you will find that this center of excellence with this thematic area in which communication and embedded and hybridization of it is the main theme. There are main five objectives of this particular center of excellence. One is IP development with the help of patents and publications to have an element of indigeneity, so that at later stage these patents can be commercialized, or it can be used for product prototype development and all. A state of the art lab facility, so R&D facility is there, so anyone who approaches us can avail this particular facility, where hardware, software and other types of tools worth of rupees 7 crores are available, which are of very advanced type. Then you will find that we fund some innovative projects which are UGPG projects, and we help them to basically get into developed into some commercially viable product or prototype, of course in the thematic area of Center of Excellence. And we have under the academic industry collaborations MOUs formulated with various universities and institutions in India and abroad, and with them we are collaborating in the area of research and academics. Last but not least, which is most important, that's why I'm taking this 5 minutes, and is the training or skill enhancement workshops or certificate courses which we conduct. And the you will find that there are various areas in which we work. These are the areas, and these are the glimpse of the various projects on which we have worked. They may be related to assistive technologies, robotics, or surveillance, or healthcare using IoT, or basically you will find that the man-machine interaction, or circular for surveillance and security purposes, or antenna designs, or expression invariant face recognition, acoustic improvement, and projects of socio-economic relevance and all, in which you will find that these courses which we generally conduct are in the area of wireless communication, or you will find that embedded system, or it can be in RF circuit design, antennas, and there are many types of courses which we offer. The peculiarity of these courses or workshops is it is totally hands-on based. There is very less part of theory in it. Each module is of 30 hours long, and generally anyone who has completed second year of engineering of electronics and allied branches can attend it. So you will find that there is a value addition to their profile. Students get their employability quotient enhanced, and you will find that if you are a faculty, your teaching delivery also gets value addition. These are the thematic areas in which these courses are available, and the resource persons are the faculty of VNIT along with the industry expert. And of every month, 4th and 15th, the batch start. The outstation candidates can complete these courses in crash course manner. During the pandemic, they got affected because since there is heavy element of hands-on, we are not conducting it in virtual mode because you have to come and attend the lab. Those who can stay in Nagpur can get it covered in 2 hours daily fashion, also in 15 days or in crash course manner. And these are the industries which are collaborating for this particular outcome. You can see the fees are very reasonable, and it is in the range of 3,500 or so. So these are the glimpse of the labs which are available, and basically anytime any kind of academic and research collaborations from anyone, either at triple IT, because I have additional charge of dean there also, or at VNIT, are most welcome. So right from 2x2 memo system to cognitive radio, software development radio, and kits like that, wireless sensor network, body area network, or if you see related to embedded system, also lot of tools and equipments are there. These are the contact credentials, and everything is available on the VNIT website also under research facility, under Center of Excellence. You will get all this information. So you people are most welcome. And my contact details are available with Dr. Kamre. So any kind of help if anybody is needing in this thematic area, they are most welcome. So now I will start formally with the talk. And as I have said, basically that we talk about AI in image processing. So we take image as a data, and basically you will find that whether it may be related to healthcare, scene analysis related to security and surveillance, or you will find that automation. There are so many applications in which image processing can be there. But ultimately, what we do is nothing but the knowledge discovery of the database, or taking out the hidden patterns and interpreting it. So you will find that in this, there is a lot of data mining which is involved. And here your data is nothing but image, and therefore it has certain what I would say is expectations or specifications for the system on which we are working. And therefore you will find that the data mining during KDD must be followed by the interpretation of the knowledge. Unless interpretation is there, there is no use. So this entire process of KDD can be in a block schematic manner, can be represented as, you will find that there can be huge raw data which is available to us. So suppose if someone is working on the MRI images or something like that, then the huge database would be there. And there would be a pre-processing particular related to data cleaning, condensation, dimensionality reduction, wrapping, description, any kind of process can be there. Now, all these processes which have been written there are in generalized manner. Related to image, you will find that there can be denoising, or there can be contrast adjustments, or you will find that resizing, cropping, so many operations can be there to bring it into some kind of pre-processed data which would act as input for the machine learning part. Under machine learning, basically, you will find that there are various activities which can be like rule generation or clusterification, or there can be classification, which is very important. So you will find that the hidden patterns in the data can be identified, and on basis of which the classification can be done. As soon as machine learning process is involved, the outcome is nothing but we get the mathematical model of the data. So here, if even if I forget, you take data as image basically. So you will get the mathematical model of the data or the patterns which will be here. Now you will find that at output, these patterns which you would be obtained is because of this machine learning technique, and that can be outcome of classification or whatever process we are following. Now, after that, the main thing is to gain the useful knowledge. One more stage would be required, which is nothing but knowledge interpretation. And in terms of that, it can also involve knowledge extraction or evaluation. Then only useful knowledge from that particular pattern of data would be obtained. So you will find that right from the pre-processing part of these images to the input or outcome of the machine learning, getting that would come under data mining, whereas you will find that classification is one sub part of it, and the entire process along when data mining is supported with the interpretation or knowledge interpretation to get the useful knowledge, then would be called as the knowledge discovery in database. That is what the figure is showing. So KDD is very, very important, and hence we can see that two subphases of it as data mining and one subphase of itself, that is classification, is very, very important. Now you will find that why data mining currently in current or recent time has become so important. So you will find that there is a digital revolution, and that has made capturing of images very easy. So best example is mobile phone. People have it, lots of pictures we take. Then in the form of, you will find that computer hardware or software tools which are very versatile and with lots of facilities can process this huge amount of data. And the data is heterogeneous in nature, so it can be mixture of lot many things. It can be text, symbolic, numeric, texture, images, whatever it is there, and can have huge dimensionality in terms of size or dimensionality as far as other parameters of the images are concerned, and it is scattered also. Secondly, the rate at which it is being stored is also quite high, and therefore you will find that there is evolution of robust or efficient machine learning algorithms to process this particular data, and all this at a falling cost of computational power, which is enabling us basically to go for computationally intensive method. So in this case, today in my talk, this classification would be focused more, as this is a prime or prime phase or important phase. And as far as this particular core phase is concerned, input is nothing but you will find that the learning which we would be providing, for that we would be giving a rule, and you will find that there would be the outcome in the in terms of classification. So we will go for either clustering or rule generation. And in general, for any application, the outcome of this classification would result into two main things: either decision making for some process. For example, if it is CAD kind of thing like computer aided diagnostics or something like that, then processing of the X-ray image would finally result into some kind of diagnosis. So because of that, the treatment or the further or future course of treatment would be decided. So either it can result into a decision making, or it can result into certain kind of prediction. For example, structure failure. So from images of certain structural element, we can predict that after so many days or under certain the kind of condition, the structure may fail, and that prediction we can do with the help of technique like image processing, of course with support of modern technologies like AI and all. So when this is there, you will find that this classification, which as a core phase faces many challenges again. So you will find that first of all, the complexity of the data in terms of huge size or large feature space, and because of which the dimensionality also is very large, and there are large variety of types in it. Secondly, data can be it can be consistent or it can be inconsistent or imprecise, or many times it can be incomplete also. There are certain elements in the data which can be missing, and because of this you will find that it results in lots of vagueness or ambiguity in the data. Secondly, you will find that it can have partially defined incomplete data also, which we can call it as ill-defined one, and that has to be processed. And because of these challenges, generally a pattern classifier which we would be dealing with or we want to have as at the core phase level, you will find that we will have these desired characteristics for that particular classifier. So the researchers all over the world are putting lots of effort to come out with good classifiers basically, and having a good accuracy as well as precision, and that's why all together we can have lots of desired specifications from such system. So it should be fast enough with minimum processing time overhead and should converge very soon. Then you will find that and this is for making it suitable to the real time classification problem. So for example, you know your diagnostic method can be 100% accurate, but after observing the image or classifying it, if it is giving decision after 4.5 hours, that's of no use. Then only for offline certain data interpretation such accurate system can be used. But related to healthcare or for certain scientific applications, time factor can be very, very important. Then the decision making capabilities after classification of such system should be very good, and it should mimic the human decision making capabilities. So that particular characteristic the classifier should have, and the accuracy and the efficiency level should be very high. So with least number of possible input parameters or features, it should be able to give highest possible accuracy. Then you will find that it should be versatile, and it should be that versatile that it can handle any kind of data which may be consistent, inconsistent, or even ill-defined or incomplete also, and with full of vagueness or ambiguity, still it should be able to handle it. And naturally, if it is able to handle it, it will also handle the uncertainty which is the outcome of this kind of characteristics of the data. Then you will find that it should have minimum or optimum implementation overhead. This also points towards the synthesizability of your algorithm. So many times what happens is the algorithm is quite good as a code, it runs and all, but when it is a time to convert it into hardware, then it is next to impossible or most impractical thing. If this happens, then this the usage of such kind of algorithm is very limited. So you will find that it should also be able to handle the complex data in terms of size and feature space dimensionality. Now, there is one very good review paper by Dr. Anil Kumar Jain, which is a pioneering paper. If you go for this, for there are various subtasks in knowledge data discovery, and for those usually various kinds of popular methods are used, and that's why you will find that among that the classification is deliberately highlighted, because we are right now discussing that particular thing. So neural networks or rough sets, genetic algorithms, or nearest neighborhood. So you will find that base classifier, fuzzy logic, so many types of learning this thing. Now, of course, this paper is a older one, though it is pioneering one. That's why in this table we can update the recent tools like convolution neural network, deep neural network, or things like that. So various other formats. But what we have is only this. These are nothing but extended types of the neural network technology only. Now, that's why it has been seen that conventionally earlier, whatever pattern classification was done, most of the time it was done using statistical approaches. And therefore, there was respective pros and cons related to it. as far as statistical approaches are concerned. So you will find that first of all, the absence of mimicking human decision making capabilities. So that was the problem with the statistical approach. And in case of large space, in terms of dimensionality and size with unlabeled data, it used to get proved very limited. So you will find that other approaches were preferred. But still you will find that the statistical approaches have a dominating presence as far as hybrid approaches employment is concerned. Then you will find that there were other techniques evolving at the same time, like fuzzy logic, so which could handle the imprecision present in the data, or also the uncertainty in the data. It can handle well. It can well mimic the human decision making capabilities and all, and therefore you will find that this method was quite promising. It could also deal with problems which are well beyond the reach of the traditional methods of analysis. So basically, you will find that that's why fuzzy logic was implemented at many places. And then you will find that the assumptions that the perceptions are described by the propositions drawn from a natural language. So you will find that the variable description was quite linguistic based, and therefore the modeling was quite easy. But there were, like, you will find that as the pattern classification and fuzzy logic, they were strongly related. The input features represented were linguistically phrased manner of processing, and then multi-class membership of ambiguous pattern it can represent. And you will find that because of that, the inferences and the rules generated also were in linguistic format. Even the ill-defined image regions or primitive properties and relations among them also can be described in terms of fuzzy subsets, and also these were the advantages. But then you will find that along with it, the following limitations were also there. So first thing is the lengthy membership modeling or computation just for reaching a simple solution. And because of this, we cannot see fuzzy logic technique as a very generic technique. So for certain applications, it is very good. And for certain applications, it can be like more than required. So you will find that this is because the first selected features of the pattern of interest are extracted and are mapped into the feature space. So you will find that it requires then exhaustive modeling of membership function of the features for decision making, and this particular increases the computational complexity and overhead. And that's why then many times such type of systems were unsuitable for real-time application, and the hardware implementation also was quite complex. So it needs metadata, that is additional information about data, that is data about data of data. And that's why you will find that as a standalone that might have limitation, but still it makes a promising it is a promising candidate for hybridized approaches and all. Then you will find that genetic algorithm also was one such candidate, and it was seen that they are adaptive, efficient, even robust also, peculiarly for search applications, producing near optimal solutions, and a lot of scope for implicit parallelism. But then you will find that in this case, wherever the what I would say is computational intensive, this thing is there, limitation is there, then this particular technique cannot be used. So you will find that, and in that case, in this particular process, there is a possibility of losing the exact solution also. And this is all because of, or this in terms of a delayed convergence, which is always there. So there would be lot of difficulties related to identifying the global minima, and the solution can get stuck up in local minima, and also many things can be there. So among different techniques now, the neural networks, which is now has become a pillar of AI technology, is also a promising candidate. And you will find that the biggest strength of neural network is their human decision making, mimicking that or capability is very, very high. almost parallel, or in some cases even better than that. Secondly, it is a general solution. So generalization capability is the biggest strength of this particular technique. And you will find that the neural network techniques can well work with noisy conditions also. So if there is lot of impurity in data, still it is well handled with the help of neural network. And it is a population based technique basically. So you will find that most of the neural networks, they search the feature space randomly or sometimes following some mathematical criteria. And the final solution either could be obtained in a supervised or unsupervised manner, and resulting into a deterministic or non-deterministic solution for various real life applications or problems. So you will find that if we use neural network, then based classifiers, then definitely it would have certain advantages. So it would have a lot of withstanding capacity towards noise, tolerance towards the distorted patterns and images, etc. So it can generalize the thing. And you will find that it has an additional capability of even recognizing the overlapping patterns also, making the classification very efficient and effective. So you will find that even classes with highly nonlinear boundaries or partially occluded or degraded patterns which are there, those also can very well be classified or recognized. And secondly, you will find that that they are non-parametric and have potential of parallel processing also. So you can make process faster, but they also face certain limitations. So there is an exhaustive training phase involved over there, and it does not employ the redundancy present in the feature space. So you will find that many times outside the classifier, the feature space reduction itself becomes an NP hard problem. And we would discuss that. So how we can employ other approaches there and get the dimensionality of the input reduced and all. So therefore, you will find that if the feature space is quite large in terms of dimensionality, then the system becomes complex and slow also. And you will find that for hybridization, when it is combined with other approaches with neural philosophy and all, then it can the overall performance can get enhanced. So from this preliminary discussion, what we see is if the pattern classification, which is the core phase of KDD, is done with the help of hybrid approaches, then you will find that that can give us lot of advantages, and at the same time it can bridge the gap. Uh, um, this it can bridge the gap basically with maximum achievable outcomes. And rather these tools which are getting proved competitive may become complementary to each other to solve the real life problems. So you will find that there can be many combinations. You can have neurofuzzy, so fuzzy logic and ANN, or it can be ANN and genetic algorithm, or fuzzy logic and genetic algorithm, or all three fuzzy logic, ANN and GA and all, like that it is there. So you will find that neurofuzzy, if you see, there are lots and lots of papers are there. The hybridization typically is very visible, and it's quite realized so far at a higher scale. And you will find that generally the advantages of such hybrid approaches are they become generic in nature, and they are application specific also, means both way you can use them. So overall, so far, like different papers, if you just go through, then you will find that if we just take a rough percentage or division of the approaches which are there, then you will find that all over worldwide, whatever researches are presented, the highest this thing the extent is of using hybridized approaches instead of pure approaches based on one technology only. So you will find that hybridized approaches have a larger extent. Next to that is based on pure ANN based approaches. So all your deep learning and other things will come under this part only. Whereas if it is only fuzzy logic kind of technique is there, or statistical technique is there, or genetic algorithm is there, So genetic basically would be very useful for image retrieval kind of applications and all where searches are involved. So that extent is only up to 6% or pure statistical is up to 10%, and also this is all based on let's say a data set of around 1,000 papers regarding this particular classification which were referred. Based on that, this pie chart has been drawn. Now you will find that among this, a new candidate is particularly evolving and is very suitable as far as this hybridized approach is concerned. So you will find that fuzzy logic, whenever comes in mind, it comes as an algorithm which can deal with imprecision and uncertainty. Neural network, when comes, we say that it is machinery for learning the function approximation even in noisy condition. And you will find that the other evolutionary algorithms or approaches, you can find that for reinforced search or optimization, etc. But if you will find that there is uncertainty arising out of the granularity in the domain of discourse, then roughset can handle it very well. Now that's why the comparison of these expert systems with other systems like fuzzy or neural, and based on that if it is made, and various ratings if they are provided, then for different tasks what kind of ratings we would have from the peer research or literature review and all that can be done. And it is found that you will find that knowledge representation, uncertainty tolerance, or things like that on which this particular weighing has been done. And you will find that neural network is a technology which is having at most of the places the highest possible score, and therefore it is very generic in nature. That is the biggest strength, and therefore that hybridized with other approaches can give you very good solution. Now, along with that, the data, when I say, means here it can be image, because our thematic area of the faculty development is image itself. But these problems with data are so general that they are available with, they are there with images also. So you will find that the problems which are faced because of data are, first thing is complexity due to very, very high feature space and dimensionality. Then the vagueness which is there in the data. Sometimes we will see now when information system is formed with the same set of features, the two objects get mapped to two different classes because of inconsistency in the data and all. There can be imprecision which resulting into lot of uncertainty also, and the data can be like either too much consistent which results in redundant effort of its classification, or too much inconsistent in which there are a hell lot of overlapping patterns and objects with same feature values getting mapped to different classes and all. Then there can be missing information or incompleteness also. So other techniques, they will get stalled or halted or may give very erroneous outcome and all in such situation. And then you will find that the indeterminacy in the data which is over there. So these are the prime problems, or we can say challenges, which we always faced in data or even images also. Now, Zezra Polak in 1981, he came out with this particular tool, giving a new set, we could say. And why I'm saying new, that because rough sets are still under explored or underutilized tool to handle all these challenges of image, pattern, data, whatever classification is concerned. So you will find that this was introduced by Pollock in 1981, and still there is lot of scope for the synthesizable algorithm implementation using rough set. So I will come to that part also in the latter part of my presentation. So you will find that this was a very promising tool, and rough set based data analysis involves basically formation of approximate concepts about data based on the available classification information. So you will find that subset takes care, or it rather extracts automatically the data of data. So it extracts metadata and is basically a tool of approximation if it is to be described in one line. So you will find that related to classification in current kind of applications, the you will find that the rough set can help mainly in what? It can help in attribute reduction, so which is NP hard problem, although, but you will find that the reduction in features or feature dimensionality of the input images and all that it can help. It can also help you in rule generation and prediction, which in general would be helpful for us to classify the patterns or things like that. And rule generation is very easy for, rather very useful for prediction or decision making. Then significance testing or the rule validation, etc. So if we are weighing the rule or attribute like that, it is there, then that also it can do. Then it can also do data discretization, including grouping of the qualitative values of the features. So you will find that if it is so, then what this thing is there. Generally, you will find that it is regarded as a part of soft computing paradigm, but you will find that now it has what we will say is has given a treatment of one of the five key non-traditional AI areas basically. So our theme is AI, and that's why I have come to this topic, which is quite unexplored, and that's why you should use it for different applications related to image classification, etc. So you will find that with other soft methods require additional model assumptions such as the ability of the collected sample to represent the priori probabilities and fuzzy functions or degrees of belief and all. In that case, rough set is unique in the sense that it is non-invasive and it uses only the information given by the operationalized data and does not rely on other model assumption. This is very, very important. And that's why it saves lot many efforts. So in other words, you will find that instead of using external numbers or other additional parameters, the rough set analysis utilizes solely the structure of the given data only. So that is what I said, that it is mainly an approximation tool which itself extracts the information from the data. So you will find that if this is the case, then um, what we can do in table, we can make a table basically, and we can find out the position of the various mining tools or technologies which is there. So you will find that uh, the whether your classification technique is microscopic, which is preliminary numeric, or macroscopic, which will involve lot of description, or whether it is deductive or inductive, means agglomerative or other way like that. So based on that, the various AI tools have been placed, and it, like for example, neural network is inductive, which is population based, and it is microscopic. So fuzzy logic is macroscopic and deductive. So you will find that for clusterification, it can help a lot. So here you will find that rough set basically analysis is inductive and macroscopic in nature. And therefore, if we want to have both natures, that is microscopic as well as macroscopic, microscopic as well as microscopic in our KDD or the data mining, both kinds of methodologies, then the rough neuro hybridization would be a very good option which can be explored, and it can prove as a very good tool as far as AI theme is concerned for image classification or image related processes. So you will find that the finer details as well the large amount of data both would get handled as far as rough neuro approach is concerned. So this is a very simple diagram. Now see, there is a paucity of time, and the preliminaries related to rough set also I will cover, because the audience should get at least some basic nature of rough set and all. But in that case, I agree that just within 2 hours that entire technology could not get understood. But just keep one thing in mind, that I will covering here the aspects of it and the outcomes and various case studies which have been resolved as far as this particular hybridization approach is concerned. So the main philosophy of the rough set is let the data speak for themselves. So from the data itself, the hidden pattern or the metadata would be extracted. That is the nature of rough set processing. and you will find that the method can work with less number of attributes also. So dimensionality reduction is a great advantage whenever rough set based techniques are used. So you will find that uh, basically it is a crisp set in nature in contrast to fuzzy set. So here you can find that fuzzy set, this membership, this thing is there. Uh, Membership modeling is there, and therefore it cannot be called as a crisp set. So you will find that this is normal crisp set with bonds of A and B, and you can derive a fuzzy set out of it having this kind of description. But when you will find that a rough set is made like E and F, which is a subset of this normal crisp set or derived from it, you will find that it is also crisp in nature. So all the modalities of fuzzy set which are there are completely inapplicable in case of rough set. But the other advantage is, and secondly, we don't have to deal with exhaustive modeling of the membership function. So in rough set approximation, the best thing is, since it is crisp in nature, its implementation with the digital hardware is quite easy in contrast to fuzzy set. So you will find that it is nothing but a formal approximation of a given set or conventional set in terms of a lower approximation and upper approximation of the original set. How that we would see. So when that duplet or dual is obtained, then in that case you will find that we would term it as the rough set approximation. So you will find that uh, this is a diagram which typically shows you that initially there are a lot of overlapping patterns and indiscernible this thing blocks are there, and the partitions which are defining these different classes which are there. So with this rough set processing, when it goes on, then finally you will find that the outcome would be one upper approximation and one lower approximation. So you will find that that indiscernibility would be exploited, and we would define two types of subsets which would be in terms of upper and lower. So what happens is because of this you will find that what are the advantages we get. So first is the granularity in the domain of discourse is quite well handled. So there is a inherent measurement of space, so feature space is explored, and we can have get it mapped to decision space also. Then you will find that the uncertainties which are arising from these deficiencies are also available for handling from the situation. Then you will find that the deficiencies which are resulting because of incomplete, imprecise or ill-defined and not fully reliable or vague or contradictory information in various stages of pattern classification or recognition. So these all can be handled basically with roughset. Then it offers a mathematical tool to discover hidden patterns in the data. So the metadata would be extracted automatically. Then you will find that the redundancies are exploited, and the dependency between the given features of the data which need to be classified is also explored or rather used. Then you will find that it approximates a given concept both from below or from above, that is by using lower and upper approximation. It also weighs the significance of the data. Sometimes even attribute weighing also we can do. And then you will find that the rough set based learning algorithms can be very well used to generate rules in a if then else manner like we do in coding, and hence a very good decision table can be extracted. And you will find that a fuzzy set based system, if originally is present, can be well converted into a rough set based system. Then it helps in extracting knowledge also from the image data or whatever kind of data which we are using. And because of that, with respect to the objects and attributes and all, it removes undesirable attributes by weighing them, and the data dependency is also studied, and you will get minimum number of subsets of attributes or redux, which would reduce the dimensionality to a great extent of the feature space. Then you will find that Because of this, the neural network improves, and its ability of generality also gets improved in turn. Then you will find that it can get proved as a viable alternative to model human decisions by avoiding modeling of membership, which is essential in case of fuzzy set. So that step is completely skipped here. As I have said, rough set is quite crisp in nature. Now you will find that the main advantage of rough set theory is it does not need preliminary or additional information. For example, some kind of priori probabilities, etc. These kind of things it does not require. So that's why you will find that even the grade of membership also, these kind of things are not required. Hence, if we go for a hybrid system using a rough set, then you will find that there would be the original data which is present, and in that case we would have a feature creation in that. And if it is a rough set base, we as well can have feature reduction also, and finally the same output would be given to the output model with the reduced number of features. So when we are talking so much about rough set, then it's when its utilization comes into picture, we should know certain mini definitions or preliminaries related to rough set. So that terminology we would go now. We will see now. So the first or the most important is you will find that information system, or acronym is IS, and you will find that it is the basic vehicle of data representation when the approach is based on rough set. So you will find that information system is in context of a single flat table, basically either physically or logically in the form of view across several underlying tables. So it can have subtables or whatever it is there. So we can thus define information system I in terms of a pair U and A, where U is a non-empty finite set of objects and A is non-empty finite set of attributes. So mathematically, I will be always in terms of a pair U and A. So U is object, A is basically the attribute. So you will find that information system actually physically nothing but it is a table basically. Now here, this is a table which is about image, which is about textual image and its feature values, and different objects are there. So we may have different letters. So let's say 26 letters are there regarding that these particular features are extracted. So the letter images are to be classified into 26 classes. Out of that, this is only a sample subtable shown here. So you will find that the column are having headings. These headings are nothing but called as condition attributes present in a information system. So information system is nothing but this entire table. What? So your complete information must be represented in the form of a information system basically. So mean deviation, variance, sigma, skew, skin color, cephalograph, this thing. So this may be related to face. I'm sorry. So that related this table is there typically, and the different attributes we have obtained the values and all. So these labels of attributes are called as condition attributes, and each row is one object. So you have seen it is a pair of U and A. So non-empty set of object means all rows. So first class means it is the first type of face image, second type of face image, third type of face image. That means any face image shown has to be classified into one of these 9 classes. So you will find that this is a class label, and therefore the last column is about decision or class label. So it is called as decision attribute. So condition attributes means the input parameters, and decision attribute means the class label in which that particular object will get classified. So for example, row number 2 means it is image of such a face that it belongs to class 2 with these typical values of all these condition attribute. So suppose if I have 1000 face images with me, this table will contain 1000 objects, 1000 rows, and each image is suppose well defined with the help of 23 features, then 23 condition attributes would be there. And let's say if each image has to be classified into 5 classes, then I will have 5 classes or class labels which would be there, and therefore you will find that 5 types of decision attribute I will have. Now the entries in the information system can be anything numeric in form of fraction or integer, or it can even be binary also, that is in terms of ones and zeros, depending on the type of the attribute and values, whatever you are using. But it won't be descriptive like fuzzy set. So now number one concept which we people must know is whenever the information is to be processed with the help of rough set, then it must be available in the form of an information system. Then as we repeatedly are saying that rough set means that duplet would be obtained or a dual would be obtained, where the conventional set approximation will have two subset, and it is called as an upper approximation and lower approximation. So you will find that this is the case. So this a bar of x is the upper approximation. So outside gray, the outside this green area, this gray square, what you see, you will find that it will have all the objects in two parts. Number one, objects which are definitely belonging to the given class, and objects which may belong, means we don't know, there is little uncertainty. Both together will form upper approximation. So that would be a bigger subset derived from the conventional set. Whereas you will find that the blue area is seen is lower approximation, which is a lower bar of x. The lower approximation means collection of all those objects which 100% belong to the given class. That means we are very sure about its belongingness to the given class, and we know that the given object belongs to that particular class. So what is bound to happen is, if the certainty of belongingness of this object to a particular class is concerned, the gray area may or may not kind of thing. The blue area is 100% sure. Therefore, from the two, if you just go on approximating and define a boundary and create a new set which is difference of the two, that's why it is a upper bar of x minus a lower bar of x. Then like green in oval shape, a boundary would get defined, and each point on this boundary would be a dual, means it will have two elements defining this particular difference of upper and lower approximation. And therefore you will find that this set what we have formed is called as a rough set. So the set defined by this boundary, which is a upper bar of x minus a lower bar of x, is particularly you will find that is called as rough set. So you will find that already I have described this, that upper approximation containing all the objects which we decisively cannot classify into a given class, this thing there. Lower approximation is there. So you will find that it is also known as positive of x, and boundary region is called as the BR of x, and whereas the upper approximation is called as negative of x. So that's why what we can say is, if the lower approximation white area is positive, and then negative is the upper bar a is this particular thing, then difference between the two would be the BR region, boundary region, which is blue checks pattern region. And that's why from the conventional set, if you minus the positive and boundary, then what remains is the gray pattern at the top, in which we are 100% sure that these objects do not belong to the given class or object. So you can see that there is a boundary region in which both types of object would get involved, which is difference of lower and upper approximation. So a upper bar minus a lower bar, and on its top and bottom what we have is the decisive collection of objects belong. Positive means belonging to that class certainly, and negative means not belonging to that class at all. So this way the rough set approximation is done. Then you will find that there is lot of intricate mathematics now involved here, but I would just tell it from the application point of view. So whenever the information system is available, then in that case you will find that we can define an indiscernibility relationship. So indiscernibility basically exploits the dependency or independency of the, for the given features between two classes, whichever objects we are. So you will find that this indiscernible relationship which we define here basically is implying that there are two objects x and x dash, and they are indiscernible from each other when considering the subset B of attribute. So by keeping only those attributes which preserve the indiscernibility relation, we can still generate the relation between the objects. So there are usually several such subsets of attributes, and those which are minimal are called as reducts. So you will find that, so kind of uncommon set of attributes which would be there, which would make these two objects distinct from each other. So basically you will find that this philosophy is defining the classification inherently. So you will find that to have the indiscernibility between certain number of objects, you can go on creating number of subsets of different attributes from the given conventional set of attributes, and out of that whichever attribute you will find that is minimum in number in the subset, that subset would be called as reduct. So reducts are very important because reduct shows that extent of dimensional reductionality, and for classifying those objects it clearly tells you that there is no need to involve all the attributes, but only these many attributes can be involved. So an analogous example to this I will give you. When we solve Karnan map, we get a minimize equation for a given logical expression. But you always know that the outcome of a Karnan map is not unique. That means using K map for the same logical function, we can have more than one possible answer. It is there. So but all answers will be equivalent. That means the number of terms in these answers would be same, and each term containing the number of variables will also be same. And then what we would see is, suppose three possible solutions are obtained for the same logical function with the help of K-map, then we see there are certain terms which are evident in all three answers, rest are variable. So those terms which appear in all the answers and cannot be replaced with any other substitute, we there call it as a core. So same way here also, in the minimal set of attribute, reducts are there. Among that, among all such subsets, the attributes which are always there and cannot be replaced are called as core. And there in tabulation method or Queen-McCluskey method, we call them as prime implicants. So prime implicants kind of attributes would always be called here as core. So basically, whenever based on rough set philosophy, when you process the attribute set, it would result into some kind of redux and core. That is what you will always do. Now, in large dimensionality using linear algebra, it would be always better for us to define it in the form of a matrix, and therefore we can create a discernibility matrix for the given information system. Now you will find that here we can see that rough sets can deal with inconsistent data, consistent data, and incomplete data also. What do you mean by this? Now see, consistent data means, for example, if you are processing images of letters, that means character recognition, if you are doing, and suppose if you are uh, having parameters like number of loops. Now, number of loops, if you see how many letters are there out of 26 letters which have loops. So there is B which has two loops, P which has one, or Q, or like that you will find that. So for all 26 letters, suppose if you have thousands of images as your data, and for these parameters, if the number of loops are found, then in this column you will find that the maximum time the entry present would be 0, because apart from B, P, Q, one or two letters here and there, the other letters don't have loops in them. And therefore you will find that in such cases the classification is quite easy, and in a table you will always find that with certain number of, for example, if number of loop is non-zero, that itself tells you that there is no need to explore all the 26 possible cases. Now it is only one among B, P, or Q, or like that it is there. So you will find that your space for search would get reduced. And therefore, when for the given set of feature, the class label is completely known, and 100% same class always we get for the same set of attribute, then such type of data is called as consistent data. And usually consistent data is less challenging. But then too much consistency always bring lot of redundancy also as far as attribute space is concerned. Inconsistent data, you will find that medical image segmentation, typically here there lots of challenges are there. For example, if I am making a table with the help of symptoms and a particular disease, so if I say headache, yes, temperature, yes, vomiting or nausea, yes, and then now problem is there can be rows related to patient with these three attribute, but the class label or the decision attribute for one patient can be malaria, another patient can be typhoid. Now here what is happening is that's why the doctor's diagnosis is very important and valuable. We as laymen may see both the disease as same, or both the ailments as same, but they are not same though their symptoms are same. Now here what is happening is one object with same values of attribute is entering into a class of typhoid, and another object with the same attribute values is entering into another class called as malaria, because in both cases headache is there, fever is there, or nausea is there. This is hypothetical example, don't go into the reality because I am not a doctor, but I have given one example. So if such kind of thing is there, that with same set of attribute values the object is getting mapped into the same class, then lot of inconsistencies there, and incomplete when the values in the rows are missing. So you will find that there are different postulations or rules, or you will find that mathematical tools which come from the rough set, and we can use them for different things. So whenever you are dealing with a consistent data, you use the indiscernibility relationship or redux or decision tables formulated using rough set philosophy. If there is a inconsistent data, then you will find that you use the philosophy of lower and upper approximation and certain possible rules which would help you for the classification. And if there is incomplete data or missing data, then you will find that you can use characteristic relation or singleton subset or concept of approximation, which exploits lot of granularity in the data, or rule induction, etc., for processing of incomplete data. So you will find that it might have happened that certain mathematics or preliminary terms which are coming now and then, so because of lot of theory few people might have got bored. So let's do something interesting now. So what better results this hybridization can give us, that we would see now. So if rough and neuro hybridization is being done, so what will happen as far as AI based this thing image processing is concerned? So we know its significance now and all this background, and with this now we will see what kind of outcome we can get. So we will be discussing the case of unsupervised neural network based classifier, and how with this rough set based philosophy can do value addition to its working, and all that we would see. So we would show you the case studies where it is dealing with consistent, inconsistent and incomplete data. So first example is the images of particularly this is a very good transaction paper by Professor S.K. Pal, who is an eminent scientist in this field and from ISI Kolkata. So you will find that this is also a very old paper, but the example is very good. So you will find that the hybridization has proved the value addition of hybridization is very evident from this. Now you will find that the training data was 20% or testing was 80%, and the classification accuracy in percentage it is there. So multi-layer perceptron, then fuzzy multi-layer perceptron, then modified fuzzy multi-layer perceptron, then with rough set, and then multi-layer rough set fuzzy multi-layer perceptron, like that. So wherever rough set based this thing is there, there you can see the accuracy of 3 features, 6 class flower images based classification is concerned. So you will find that wherever rough set is involved, you are getting more accuracy with the same extent of training and testing data. then you can see here with this particular rough fuzzy neurohybridization, the network size, the white bar you can see is reduced to a lot extent, and just see where the main thrust is on fuzzy, the brown bar, you see the number of links in the network are more than 200. So you will find that the network size optimization, because of hybridization of such kind of AI techniques with rough, has reduced to a very larger extent. So you can see the number of links are even lesser than 100. So you will find that the size reduction you get as far as network is there. Then training network. So you can see the 400 megahertz nowadays is considered to be very lower frequency, but we can appreciate Professor Pal that during 90s he already could discover the promising nature of this particular tool and has gone for this hybridization approaches for classification. So that's why, though the paper is old but is very fundamentally very good, you should refer this paper. So you will find that the training time you can see with that alpha workstation, even at 400 megahertz, least time is required with the rough set based hybridization. So you will find that what different approaches then now we can have. Now this is particularly few of my scholars and our team, the work has been done and explored so far. In a gist, we can say that the rough set based approaches for such AI or neural based image processing classifiers or whatever systems are there, you can implement these at pre-processing level for dimensionality reduction, or you can use this philosophy at training level, or you can also use it as architectural level to prune the size of the network, as we have seen the number of links can be reduced and all, or even we can get the structure of the neuron modified with the help of the rough set philosophy. So basically you will find that because of this, these are the various issues which would get uh, covered or handled well as far as pre-processing level is concerned. So this we have already discussed. So now you will find that case study of attribute reduction. So what has happened is, if you use now attribute reduction is a NP-hard problem, non-deterministic polynomial, and you will find that it is like a traveling salesman path reduction problem. But still with rough set you get very good results with attribute weighing and all, and these were the algorithms. Now due to paucity of time, actually how these thresholds have been worked and cutoff are work and cardinality of those sets are worked out and all, in this time typically it cannot get covered, but just pay attention to the outcome which is there. So you will find that what was done, the case study was taken in terms of a proprietary data obtained from a semiconductor industry, and sample parameters have been shown like voltage, current, temperature. So the wafer under inspection related data was there. So what is happening actually, that has been represented in this particular figure. Now you will see that if n attributes are there, the dimensionality can directly go towards n square if the one-to-one comparison is being done. So what rough set based data analyzer is doing is, it is reducing the number of attributes and the reducts are obtained, and then they are given to the neural network classifier for classification. In such case, we get a very promising result for the real-time application for the wafer classification as far as this semiconductor industry is concerned. You will find that since it is crisp in nature, you can have improved class discretization algorithms for your features. I would just skip this part because there is a lot of mathematics which I will have to explain, but the results would be more important for us. So how the reduced feature space create wonders for us, and multiple methods can be used, and you will find that they would result into the the attribute reduction, and related to that graphs I will show you at the further stages. Then at learning level also you can involve the rough set philosophy. So we have taken a case study of unsupervised neural classifier, in which we have seen the winner take all algorithm based classification was a promising candidate. So in general what we do is for whatever response it is there, we see the winner node, and uh, in winner take all, generally you will find that the only the winner weight is modified as far as neural training is concerned. But a fuzzified or modified this thing winner algorithm was there, in which these sides of the triangle are representing the Euclidean distance of the other nodes from the winner nodes, and based on that, proportionally the weights would be updated. That means not only the winner node only updated, but other node also would be updated. Here only now the fuzzified rule was replaced by the rough set philosophy, and it was decided that we would go for the lower and upper approximation of the set of the output neurons, and those would get modified, and the proposed learning algorithm based on rough set philosophy was made. Then the rough set philosophy was used at architectural level also. The results of all this I will show you in a comparative manner what has happened actually there. So you will find that Dr. Lingras, a scientist from Canada, has come out with the modified structure of neuron on rough philosophy, but that was not explored for the unsupervised neural network. So that particular work was done, and an architectural modification was done. So instead of a plain neuron, a modified rough neuron was involved. Now, a modified rough neuron is a collection of two neurons together, receiving two sets of inputs or attributes. One gets the upper bound approximated set of feature, and other would get the lower bound only. So in simple language, this is a kind of like coarse tuning and fine tuning. So you will find that with redux with the lower bound, whatever inputs are there, that particular neuron will converge earlier, and the remaining residual convergence or learning would be helpful for achieving the required accuracy with the help of the entire set of the attribute. So combining the result of the both, finally the output would get defined. So what we have done that the rough neurons in the regular neuron, they were replaced at the output level. So you will find that at input level our regular neurons are there in the architecture, but at the output layer the rough neurons were there, which are paired with the lower and upper bound. That's why two dots, one with blue and white, has been shown. And with that the collective response or the combined response was obtained at the output, and we would see how these were trained and what kind of results we got. Secondly, architecture optimization or pruning of network was also obtained. So what we did was a decision making algorithm was designed based on the rough set philosophy for pruning the network, and with that you will find that the link were weighed, and if we remove the link, then what happens, that particularly was seen the cost of the error because of removal of link was estimated, and because of that two bounds of the errors were worked out, which are here given by equation number 17 and 19, and the result finally gets validated by the mean value theorem. So you will find that with these two things, we every time see that if this link is removed, what will be its impact on the accuracy of the network, or will there be any problem or loss of information. So with this we go on removing the links, and the architectural size gets pruned, and the network optimization is also done based on this philosophy of rough sets. So you will find that different case studies then were taken, and for these were the rules which were generated or postulated for handling the incomplete set of data, or which is quite similar to Queen-McCluskey method. So it is a kind of approximation basically, and then you will find that based on this the various kinds of rules were worked out for processing the incomplete data. Now based on this, even the hardware implementation of the this particular classifier was also tried out with the help of FPGA and all. So the case study data sets were taken for these three approaches, that is at the pre-processing level, learning level, and architectural level. And then you will find that these were tried out on various data sets that I would show. So first case study was character recognition. So 18 types of different fonts were there, and you will find that as I have said, different attributes were there. So the pre-processing was there with the images, so which was having cropping, binarization, etc., boundary extraction and all. And then you will find that these are the pre-processing algorithms. So I would just skip those. And then final information system was obtained in this way for rough set based processing. Then this was one particular case study. Second was face recognition. So there was a very good database which was there by IIT Kanpur, and that was used, which was there by Professor Amitabh Mukherjee. And various orientations or face angles were there for the Indian faces and all. And there was some pre-processing related to it there. So again, information system was obtained like this. And then now the results for these different case studies we could see. So you will find that these are the results as far as convergence or learning rate and required epochs are concerned. And you will find that the classification which is there for different case studies, the results have been shown here. So you will find that here there is a comparison. So now in this case you will find that these are the approaches like pure neural approach, or basically the approach with the rough set, or statistical approach and all. For different learning values, these are the results, and these are the classifier responses for hybridized approaches, that is for different case studies with training sets and all. So these are the results. Now, typically, I will show you the screenshots of those applications where you can know. So these are the outcomes for the this thing, consistent data. This is for inconsistent data. And then you will find that pre-processing level was when there. The reduction of attribute has resulted into earlier convergence and very good accuracy. So after pre-processing, the response is improved again. Now you will find that there was a discretization method, also four methods which were worked out based on rough set philosophy. So we could see the reduction methods also and their results basically. And amongst all, we can see what kind of classification accuracy is obtained. So the method number 4 and method number 1, they are like quite useful as far as this discretization is concerned. And based on that, the classifier response again was seen. Again, the now here you can see neural network with redux for different case sets with for a fixed learning rate, what kind of response it is there. So for different case studies, means whether it is face image data or character recognition data, this hybridized approach was worked out. So you will find that when pure neural approach was there, the classification accuracy around 94% was there, learning rate 0.4, but the number of iterations are 1000. If we go for pure neural with redux, basically at pre-processing level, still the iteration are remaining same, and some more rather the classification accuracy has reduced. But if we get rough neural, you can see to 1/10 the number of iterations have reduced, and the promising accuracy is again there, which is almost comparable. This is for character recognition. Then you will find that for face recognition, which are based on this thing, um, uh, what I would say is different approaches. So pure neural with redux and rough neural with redux and all. You could see naturally the last case is the best one. So accuracy is almost consistent against all epochs we could see. And the same is there with the what different types of networks which is there for case study 3 of face recognition data which was there. So again, there was one application related to mobile handoff prediction. These results are related to it. So wherever huge data is there, you can process it, and you can see the reduction in number of computation also with different approaches, whether it is at learning level, pre-processing level, or rough neuron level, or what. So you will find that if this is the case here, the actual application made by it and all the screenshots you can see. So when you select this particular data set or information system, and then which approach you are using, based on that the outcome we can get. So interesting is the for the phase study. Here you can see whichever image is loaded, the output image which is been shown. Even if there is the variation in the expression, typically you will get the output image from the set for the same person. But for missing information or this thing is there, then you can see with pure neural approach the wrong kind of output we get with the feature space reduction. But when rough neuron is used, again the corrected output is obtained. Then you will find that when missing data is there with your conventional approaches, what you get is uh, wrong output. But when characteristic relationship used with rough neuron or rough set philosophies are used, then you can find the corrected output is there. So you can see even if the angle or there is a variation in the tilt in the neck and all, the same person image would be searched and all. So there were lots of data regarding the mobile handoff prediction and all. Now, before I conclude, last but not least is we even have done we have taken certain efforts related to the hardware implementation of these rough set processors or data accelerators, which can make computations very fast, because such efforts were taken by Kenusugi in around like 1980s, and after that surprisingly no one has taken this in. So you will find that there is a lot of scope. So now the challenge is we like process many kind of application related data using AI techniques and all, in which image is also there. But we should have a result oriented hardware implementation of the same. And therefore you will find that typically even the computer aided diagnostics kind of things are there. These applications also can give very good data or good output as far as rough set philosophy is concerned. So you will find that this was typically like one such application in which the rough set near set approach was used for medical imaging approach. Now related to that, there are many algorithms which, due to paucity of time, I won't be in a position to explain, but you will find that the tolerance towards the variation in the intensity, and because of the image characteristic which is varying because of the varying technology, whether it is a normal X-ray or digital X-ray and all. So you will find that rough set based philosophy has always given very good results as far as feature extraction, reduction, classification, recognition, and even the tissue recognition or its classification into malignant, benign, etc. These things are concerned. So you can see here, you will find that even the extended type near set could be used for obtaining better result. So these results were then compared with the results of the conventional algorithms like rough k-means and all, then modified rough k-means. That means k-means again was modified with the help of rough set philosophy. And then you will find that based on this, the typical outcomes were compared. So Otsu segmentation was there, or whether it is near set based approach is there, or rough set k-means is there, and then could have good publications on this. Now, for all such application, the biggest challenge is you will find that the implementation or hardware implementation of this particular thing to make these algorithms what synthesizable and all. For that, one of my research scholar, Kanchan Tiwari, has worked on this. So that is what I was talking about, that hard computing is also equally important if image is to be processed using AI techniques and all. And I would just go to the result and will show you that information system processing she could implement using the rough set data processing accelerators. So this blue block she has designed, because of which you could get decision rule directly postulated in a very fast manner. So the basic work was done by Kenesugi in 1980, that was extended, and again we started to find out possibilities of implementing this discernibility and reduct creation algorithms into hardware and converting them into hardware and implement it. So this is the FPGA Spartan 6 board, which was uh, used for implementing this, and very promising results were obtained. These things then can be used for portable computer-aided diagnostic tools and all, which would be used in the area of medical image segmentation or classification, etc. So tools are AI, but here the main focus is on its implementation, basically using hardware. So converting it into a technique of art computing, basically. So then it was then used for different these things. So one of the case study application was smart grid related thing, and a system on chip kind of approach which is there, that can also be used and can be explored as far as future scope of this work. So this is my picture when I got a lifetime opportunity to meet Lotfi Zadeh, who is inventor of G-Logic and was eminent professor that time in UC Berkeley. And after my visit, after 6 years of my visit, he's no more now. But even at the age of 85 plus, also he was quite enthusiastic at that time, and it was a very memorable moment. So thank you for providing the opportunity to discuss few things. So in conclusion, I would say that conventional AI techniques which are present, they are very promising, but yes, there is lot of scope again for you for implementing the hybridization technique again. And you can hybrid this, you can do lot of hybridization of these approaches with the other effective tools also to get promising results and all. So thank you. If there are any queries or so, I would be happy to answer. Am I audible?
Yes, sir, you're audible. Participants, you may ask any queries that you have. I guess there are no queries from the participants.
Okay, so anyhow, see, my contact credentials are already available with you. So you people can contact, because always some new techniques are there. The you cannot become master of it just in one session. So that I admit. And one thing is there, when no queries are there, there are two possibilities. Either everybody has understood everything or nobody has understood anything. But then as a teacher, I will take benefit of doubt and would opt the first option. So it was a wonderful experience for presenting the things with you people, and any kind of query at later stage if you have, or any kind of collaboration or assistance if you need, if you feel, then for that it is always welcome. So thank you for providing me this opportunity. Thank you.
Thank you, sir, for accepting our invitation and taking out time from your busy schedule and giving us this wonderful talk. Thank you once again.